Hello. In this video we're going to watch a RAM 2500 Cummins diesel go through an active DPF regeneration cycle. The video is in real time so that we can see exactly what's taking place on the 4 parameters that we will be monitoring. It will take about 18 minutes to complete. We're going to watch the DPF pressure, which triggers the regeneration cycle. We're going to watch the exhaust gas temperature, which is sensor 1. It's the closest to the engine manifold. We're going to watch speed. And we're going to watch the DPF outlet temperature, which is the most reliable indicator. The regeneration cycle is starting now. We are using an Edge Insight CTS monitor to observe these 4 parameters. You can see at the very top of the monitor there's a small red light on the power button, which indicates that a regen is taking place. The DPF outlet temperature is rising. Raw diesel fuel is being injected into the exhaust system, which is ignited at the DPF filter. An active regeneration process will take place at any speed, from an idle or in neutral. However, it will be discontinued when the vehicle is placed in park. We will bring the vehicle onto the highway where we can establish a 55 mile/hour constant speed so that we can better monitor the differential pressure of the DPF filter as well as the other indicators to see when the DPF process is complete. As mentioned, this video is in real time to give you a better indication of the time that it takes to do an actual regen. You can usually expect 15 to 20 minutes for an active regen, depending on the amount of soot in the filter. The truck is being maneuvered at slow speeds due to conditions on the highway, but eventually we will bring it up to 55 miles an hour. As the DPF outlet temperature rises, we can see that the exhaust gas temperature rises to a point but stabilizes. In normal driving conditions, when a regen is not taking place, the exhaust gas temperature and the DPF temperature eventually stabilize as the temperature of the engine exhaust works its way back to the DPF filter. This is because the exhaust gas temperature is high enough to burn the soot without having to use ignition of diesel at the DPF filter. So when towing or running empty at normal highway speeds, anywhere from 55 on up, the system will do passive regeneration. In other words, the soot will be automatically burnt off the DPF filter due to the higher exhaust gas temperature that is working its way down to the DPF filter. In stop and go traffic, the exhaust gas temperature does not reach the critical temperature which is required to burn soot, normally above 500 degrees. But the active regeneration process will automatically take care of this. I have seen regenerations anywhere from 75 to 150 mile increments, depending on the amount of soot being generated by the various driving conditions, boost, acceleration, idling, etc. The exhaust gas temperature will run slightly higher than normal when an active regeneration is taking place. But as you can see, the DPF outlet temperature is slowly climbing away from the exhaust gas temperature. This is completely independent of vehicle speed. The Cummins RAM regeneration process is automatic and does not require any input or action from the driver. If the vehicle is shut down during a regeneration, it will simply start back up once the vehicle is started and placed in drive. Without the CTS monitor, I have found it very difficult to know when a regeneration is taking place. Some owners report a different sound in the engine. Some report a smell. The only thing that I have noticed is that when the vehicle is stopped during a regeneration, the DEF fluid pump is pumping faster than normal, and that is probably the most positive indicator that the vehicle was shut down during a regen. There is no harm in shutting down the vehicle while an active regeneration is taking place. However, many short trips would eventually create more soot than can be burnt off. If this happened, a panel indicator would show that the DPF filter is approaching full, and at that point it would be best to take the vehicle out onto the highway and run it until the entire DPF process has completed. As we continue, we can see that the DPF temperature is now 980. We're at 55 miles an hour, and the differential pressure is 0.5 pounds. As we continue, we can see that the exhaust gas temperature is stabilizing at about 685 degrees Fahrenheit. This is a little higher than normal due to the higher DPF temperature. Normally, exhaust gas temperature at 55 miles an hour would be somewhere in the 600 degree range. Additionally, we will see the DPF pressure decrease as the soot is burnt off. We are approaching 10 minutes into the process with approximately 8 minutes left to complete the generation cycle. Let's observe the monitor as we approach the maximum DPF temperature. As mentioned, when towing or at highway speeds, passive regeneration takes place, which makes the vehicle very efficient because fuel is not used for the passive regeneration process. Notice that the DPF pressure is beginning to fall. This is due to soot being burnt off of the inlet filter. The original starting DPF pressure was in excess of 0.5 psi. We are approximately less than 5 minutes away from completion. Notice the DPF temperature increase as we approach the end of the cycle. DPF pressure continues to fall. As you can see, we are slowing down due to speed limit and also turning around as we approach the end of the cycle. Also note that DPF temperature remains constant even at the low speed and lower exhaust gas temperature. As mentioned, this is because the DPF process continues with fuel being injected to continue the burn. Note that the active regeneration light has now gone off and the regen process is ended. Also note that the DPF pressure has dropped dramatically from about 0.5, 0.6 or so to 0.17 at 55 miles per hour. The system will now return to its normal operating temperatures and running mode. Now we will fast forward a few minutes to see what our final temperatures and pressures are. Notice that our final DPF pressure is 0.14 at 55 miles per hour. which is considerably lower than the 0.5 we saw originally. Also, our exhaust gas temperature and our DPF temperature are stabilizing at the normal temperature. This concludes the video on the RAM regeneration process. I hope this has been helpful. Thanks for watching. Adios.